So what exactly is distillation and when is distillation used? We studied about the electron displacement effect in covalent bond. Organic compound is volatile at particular temperature and I can collect it. It has organic compounds which has very close boiling point. The boiling point is not much far apart. This method is used to purify liquids with a very high boiling point. Hello my dear students, welcome back to session 6 on the chapter Some Basic Principles and Techniques in Organic Chemistry. Last class, we studied about the electron displacement effect in covalent bond. Also, we studied about the two methods of purification, that is sublimation and crystallization. Today, we'll study some more methods of purification of organic compounds. First method is distillation for today. So what exactly is distillation and when is distillation used? Now distillation process is used when your organic compound is volatile, that is it will go from the liquid state to the gaseous state at one particular temperature called as boiling point, and it is volatile, the boiling point is lower and your impurities does not go into the volatile state at all, that it does not convert it from the liquid state to the gaseous state. Or this process is used when the impurities and the organic compound has a large difference in their boiling point. Okay. So what exactly is distillation? How are we doing it? For example, we have chloroform whose boiling point is 334 Kelvin and aniline whose boiling point is 457 Kelvin. Now, these two liquids are mixed or they're in a mixed form. Okay, I have chloroform and aniline which is mixed with one another and I want to separate it. How exactly we are going to do that? Now, for example, I want to separate chloroform from aniline. So, I have a mixture of chloroform and aniline. This has got 334 Kelvin as the boiling point. This is 457 Kelvin and I have got the mixture and I have taken them in the round bottom flask. Now, this is fitted with a thermometer. Also, it has got a condenser. Condenser means here you can see this is the tube from which the vapors are coming. Here there is an outer jacket for that tube through which you are passing water and from here the water is coming out. It is the outer, you have to just imagine there is a pipe and outside there is one more glass jacket kind of thing where the two liquids don't mix. Outside the water you are giving one inlet and one outlet so that whatever vapors come they get cooled very easily. So we call that as condenser. Okay. And then from the condenser whatever is condensed, here the liquid substance is collected here. Okay. So now I'll start heating it. Which is more volatile? 334 Kelvin, that is chloroform. As I am boiling, the thermometer shows me 334 Kelvin. I can find vapors of chloroform coming. They'll come into the condenser. Here it will form condense and I'll get chloroform separate. Okay. Now, if I continue heating at 457 Kelvin, I'll get aniline. So, two temperatures are far apart. Chloroform I will get first, at is 334 Kelvin. Once I collect all the chloroform, if I continue heating more, then aniline will be coming at 457 Kelvin. So, this is when the two organic compounds or the impurities and the organic compound have different or boiling point is far apart, or maybe only my organic compound is volatile at particular temperature and I can collect it, impurity will remain back in the round bottom flask. So this is simple distillation method which we use. Now, if the boiling points are not very far apart, then we can use fractional distillation method. Now, what is fractional distillation method? Here you can see it's an oil bath, direct heating is not done. We use an oil bath, round bottom flask which is connected to the fractionating column with packing. Usually glass beads are there which is packed here. Okay. Now this is the liquid to be distilled. Okay. And again you have a thermometer, and also you have a condenser, adapter, and you have a distilled liquid collector you have got. Okay. Now here the liquid to be distilled, okay, has organic compounds which has very close boiling point. The boiling point is not much far apart. Then what will happen? As you are heating it, the one with the lower boiling point slowly can move through these glass beads and come out, whereas with the higher boiling point gets trapped in this glass beads. They do not come out to the condenser very soon. So that's the reason that glass beads are kept. So what happens? The one with the lower boiling point, the one which distills first, that is small molecule, and also it can pass through these glass beads. It comes out faster. And the one with the higher boiling point gets trapped in these glass beads, and the one which comes first is condensed faster and it is collected. The one with the little higher boiling point is trapped here and it will fall back here if you cool it down. Okay, so this is fractional distillation method. Next method is distillation under reduced pressure. Now what is this, or when do we use distillation under reduced pressure? See, this method is used to purify liquids with a very high boiling point, and they will decompose before they go into the vapor state. That is, before their boiling point comes up, before that only they will undergo decomposition. Okay, such liquids we can distill using reduced pressure. So what we are doing here is, here we take the liquid to be distilled. We have a capillary which is there to regulate the air to go out and come in. Okay, there's a stop clock here to just for regulation. Whenever is required only we will open it, otherwise this inlet will be closed. Okay, and now we have a condenser. Here we have a thermometer also, and you can see to the collector there is a vacuum pump which is there and a manometer to adjust the pressure however we require. Okay, so I'll reduce the pressure such that at lower boiling point only the liquid is distilling out. It will not go to its original boiling point. Okay, so I will reduce the pressure in such a way that the liquid which I want to be distilled out will distill out at a lower temperature, and I will not allow it to reach its original boiling point, because if it goes there it will already decompose. Okay, so here slowly the pressure is reduced using vacuum pump and manometer just to regulate the pressure we require it, and slowly the liquid will distill out, it will get condensed and it is collected separately. Again there is a condenser for the where there is a water inlet and to the sink which is there, so that it will be condensed faster. We should not allow it to decompose. So at a lower boiling point only the liquid will distill, because the pressure is maintained such a way that it will distill out at lower boiling point. Remember, boiling point of a liquid is when the pressure here inside is equal to the atmospheric pressure. Okay, so here the pressure is regulated such that at a lower boiling point only the liquid will distill out. Okay, so that's about the distillation under reduced pressure. Next is steam distillation. Now what is this steam distillation? Steam distillation means I am using here for such compounds which is steam volatile, means with the steam it can come out. Okay, with the steam it will become volatile, it will get converted to the gaseous state, and along with the steam it will come out, but it is immiscible with the steam. That means it will not mix with water once it is cooled down. Steam means what? It is the vapor form of water, correct? No? So what is it? With the steam it will come out. During distillation, steam and my volatile compound together it will come out. But once it is condensed, the distilled liquid and the water, that is the steam, when it condenses it will form water, isn't it? They are immiscible, they do not mix with one another. Only such cases we use steam distillation. Now in this case what we are doing here is, we have water, in this one we have water, okay, and here you have the compound to be distilled. So first you heat this water, it forms steam, and that steam will come here to the compound to be distilled round bottom flask. Okay, here now the steam will mix and it will take up the particles along with that, and it will go to the condenser, and here it will get cooled and it is collected. When it is collected, you can see water forms a different layer. The compound which you wanted also will form a different layer because it is immiscible. Immiscible andre mix agala. Okay, it will not mix with one another. So water you remove out and you get your distilled liquid very easily. Okay, so this is steam distillation. Next one is differential extraction. So under distillation, we learned one simple distillation, then we learned fractional distillation, then we learned distillation under reduced pressure, then we learned about the steam distillation. Correct? 4 different methods we have learned. Now it is differential extraction method. In this method, it depends on the solubility of the organic compound. Now organic compound dissolves in water, but it is more soluble in the different solvent. Okay. Now for example, water has got my organic compound. This is the differential extraction funnel which we use. Okay. Here there is a knob for removing out my liquid, and here there is an inlet for pouring our liquids which has to be extracted. So organic compound in aqueous layer means with water my organic compound is dissolved. So that is forming one layer. For that you are adding a solvent layer which is usually another organic compound. Okay, organic liquid, any liquid. Now what happens is I continuously shake this particular funnel. Okay. After shaking, what you can observe is the organic compound what was there in water, now it is there in the solvent. So organic compound is more soluble in the solvent than that of water. So what will happen? Organic compound which was dissolved here has slowly moved into the solvent layer. Now after shaking for quite some time, keep it aside so that again they will form 2 layers. Remember, these two, water and the solvent layer, should not mix with one another. It should be immiscible again. Immiscible andre mix agala. It will not mix with one another. Okay. So now the organic compound is there in the solvent layer, and here you have only water layer. Open the knob, remove the water. Your organic compound is there in the solvent. Okay. Here, only when the organic compound to be extracted has different solubility in water and solvent, only then you can use this method. Otherwise, we cannot use this method. Okay. So, do you think by doing it once you will get the pure organic compound? No, we have to do it several times to get the pure organic compound completely into the solvent layer. Impurities, of course, will not go into the solvent layer. It will remain in water, thus it will be removed. Okay. Next method is the chromatography method. This is a very important method for separation of the particles, or separation of the components, or purification to find out whether the organic compound which you have is pure. We use chromatography method. In chromatography, the basic principle is the organic compounds can be separated based on their movement through the porous medium called as the stationary phase. So there is one stationary phase through which the organic compound can move. Okay. And there is one more phase which is called as the solvent or the gaseous phase, that is the mobile phase or the moving phase. Okay. So there is a mobile phase and the moving phase, and there is a stationary phase. So the organic compound is moving through the stationary phase under the influence of the solvent or a gas, which is the mobile phase. This is the basic principles of chromatography. And chromatography method is broadly classified as adsorption chromatography and partition chromatography. So first we will learn adsorption chromatography. Okay. Now what is adsorption? Now if this is the surface of a metal, okay, on the surface of this the gas is getting attached, any gas, okay, this is maybe hydrogen gas I am taking, is getting stuck or attached. This process is adsorption. On the surface of something, the other particle is coming and getting attached, okay, temporarily. Then we call it as adsorption. If it goes inside, we call it as absorption. Just like water and sponge. Water is there, you put sponge on that, water will be absorbed by sponge. That is, water particles will enter the sponge. In adsorption, it will not go into the bulk, it will be there on the surface, it will be stuck on the surface. Okay, that's the difference between adsorption and absorption. More about this you will study in your second year. Now, what is adsorption chromatography? It is based on the fact that the different components are adsorbed on the adsorbent to different degrees. Okay, so different components have different adsorption capacity. So some of the component can get adsorbed very easily. Some on the same surface cannot get adsorbed at all. Some, it not a very good bond is there between the adsorbate and the adsorbent. So based on how well it is getting adsorbed on the surface of the adsorbent, based on that, this chromatography method is there. For example, the first one is the column chromatography. Okay. Now, in column chromatography, it just looks like the burette, okay? A huge column is there. Here, glass wool is there so that, the beads will not, the silica or the alumina beads cannot flow down very easily. They put glass wool, okay? Above that, there is a adsorbent, stationary phase. That is, it may be silica or alumina gel, okay? It can be silica or alumina. You all have seen that small jelly kind of balls which is there. It is made up of silica or alumina, we tell. Okay. So that silica or alumina gel is there in this column. It is packed. That is the stationary phase on which what I want to separate can get adsorbed. Okay. So now I have a mixture of A plus B plus C. In one solvent, I have got the mixture of A plus B plus C. So, this mixture of compound, I will add to this stationary phase. Okay. Now, what will happen? Maybe A gets adsorbed very easily, B is getting adsorbed late, C is not getting adsorbed at all. Okay. So, what happens is, A is getting adsorbed at one position. After some time, B and C are also getting adsorbed. You allow it to stay for some time. You run through that. Okay. Now, next I am going to add a solvent or an eluent, we call it as. Okay. Now, this A, B, C components, okay, which is adsorbed very much, tight agi adsorb agide. It is bond tightly to the adsorbent, to the stationary phase. That will not go to the eluent very easily. Okay. So, what will happen? It will not go to the eluent very easily. You can see here also. First A got adsorbed, then B, then C. 3 different places it has got adsorbed. Now, I will add eluent. When I add eluent, the one which is adsorbed very easily will come last. The one which is adsorbed, not where the bond is not. Now, for this is the adsorbent. A is got tightly attached to the adsorbent. B has got a loose bond. C has got a very loose bond here. Okay, very weak bond I can tell. So, when I add the eluent, C will go first in the eluent. So, first C will come out. Okay. Then, I change my eluent or the same eluent continuously when I am adding. Slowly B will come out. After some more time, A will come out. So, the eluent added can either be changed. It can be 3 different in which C has got more, affinity towards the eluent and thus easily it will come out. Or it can be the same eluent but slowly different components are getting separated. So, this is column chromatography. Once again, we shall read this. In this method, the suitable adsorbent like alumina or silica or Fuller's earth is packed in the column in the burette like long tube which acts as a stationary phase. The mixture to be separated is dissolved in a suitable solvent and the solution is poured from the top of the column of the adsorbent. The component which is adsorbed strongly gets adsorbed at the top. The one which is weak, it goes down. The other components which is in decreasing order adsorbed held up different zones in the column chromatography to form bonds, and to remove that we add eluent where the component has got more affinity towards the eluent than the stationary phase, and then it is separated. Okay. Next is thin layer chromatography. Even this is a kind of adsorption chromatography only, the second type of adsorption chromatography. In this method, we use glass plates in which the adsorbent is coated. Okay, so it just looks like this. We take glass plates in this which we have the layer of the adsorbent. Okay. Now on top of that, I will add 2 drops of the mixture which I want to separate. 2 drops of the mixture, and then it is kept in this glass jar in which there is a suitable solvent. This solvent should be suitable to separate this mixture. Okay. Now I'll close this container and keep. So after 5 minutes, you can see the particles are moved in 3 different spots. It is moving slowly, it is moving up. It is getting separated. After 10 minutes, you can see, here you can see one particle has moved only little, one has got still farther, the other one component has got still far. Here also other component, one is in one direction. That means it is getting adsorbed at one particular position. It may be dependent on their molecular mass, or it can be dependent on the size of the particles or the adsorption capacity. It is moving slowly. The bigger the molecule, lesser it will move. Smaller the molecule, more it will move. Okay. Not only molecular size and mass, it also depends on the adsorption capacity. So it gets adsorbed at particular degree, it will move, and it gets adsorbed at particular distance. Now you should allow for the solvent to move up to one position, and then you have to stop, you have to remove it out. So how much it is moved, okay, the solvent has moved up to this plate till here it is moved, and that is called as B. You take the length of this, just measure with a scale, it is B. Now you want the RF value of this particular particle, so it is moved from here to here, that is A. So the RF value is distance travelled by the component divided by distance travelled by the solvent. We call it as RF value. RF value is retention factor. Okay. So by just taking the standard RF values, I can make out which are the components which has got separated, or I just take out from here, just take it out, put it in a particular solvent where I am getting my components separated and my silica or the alumina gel separated. Just by filtration, I can remove it out. So the different methods of separation. So this is thin layer chromatography. Okay. Next is partition chromatography. It's based on the same principle, but here there is a difference in tendencies of the substance to distribute or to get separated. Okay. So we using the same stationary phase and the mobile phase. For example, we are taking a paper chromatography is a type of partition chromatography. This is the paper which I am taking, filter paper of different pore sizes come. Okay, I'll add a drop just above the solvent, and a small piece of paper should enter the solvent phase also, or the mobile phase. And here is the drop of liquid what I've added which I want to separate. So slowly I will allow it to run. Okay, by capillary action the solvent will move slowly upwards in the paper. You can see here I've got one patch, then one patch, little above one more patch, and one more patch. This is again the distance travelled by the solvent. Now I want to find out the RF value of this yellow color, xanthophyll. So I'll calculate the distance travelled by this component. So A by B, I'll get the RF values. So I'll calculate the RF values, okay, and I'll see, or it will match with the standard RF value chart and get to know, okay, this patch is keratin, this is the xanthophyll, this is chlorophyll A, this is chlorophyll B, this is the leaf stain which I added. Okay, so this is how paper chromatography, the component gets separated based on their adsorption or molecular mass, or it can be based on their molecular size also. Okay, by the RF value calculation, we can compare and we can find out which actually components were there in my mixture, or whether the components what was there, it was completely pure with different impurities was present, or which is the impurity present. All of this we can get to know by using chromatographic methods. Okay, so that's about the methods of purification. Next class, we'll be learning about qualitative analysis of organic compounds. Okay, so thank you, my dear children. I hope you have understood today's class. Stay tuned, stay focused.